16 years and has enjoyed the last 6 years doing independent development for iOS and other mobile platforms. As an early adopter of Xamarin.iOS, he's also enjoyed being a member of the Mono community and does his best to share what knowledge he has gained. He lives and works in Seattle and can be found up a mountain off exit 34. So with that, right. Frank Kruger.
Hi. Okay, don't clap. Come on. So this is an intro talk. I really should have gotten a better understanding prior, but how many people here are already familiar with programming iOS? Okay, it's going to be perfect audience for an intro talk. Android, then? Is that? Oh, okay. Well, we just have we have a mixture, I would say. So this is our agenda. I'm going to run through the iOS APIs, every single one of them in alphabetical order. All the overloads, too. And then we're going to focus in on one, what they call a layer or kit called UI kit. And this is the most important one because it's how you create your UI in your app. And you really don't need anything else but a UI in your app. So then we're going to conclude with a demo of you watching me type nervously and frantically. So I didn't know I was going to get an introduction. I wanted to introduce myself so that someone did a good job of it. So here I go. My name's Frank. These are really just my bona fides. I want you to understand why I'm not qualified to give this talk. I've been a .NET developer since .NET 1.1. My first app in the App Store was December 2008, and I wrote it in Objective-C++. You all know Objective-C, but did you know that Objective-C can actually run on top of C++ instead of running on top of C? So you can mix two object systems and create real beautiful code. With it, I created my first app called Seattle Bus Map. I was the first on the iPhone to do vector maps in an OpenGL view. It's all live rendered in real time, animated buses coming down from a server. And I even did this cool 3D view. I was way ahead of the curve, except I had no topology maps and mine crashed a lot. And it was blurry. This ran on the first iPod Touch, the little piece of crap that has no CPU in it. It still ran on that. In the summer of 2009, I started on Mono Touch for various reasons, the most important being C# is a way better language than Objective-C++. My first app that I released was for the iPad. This is my first Mono Touch app, and it's an RSS reader and podcast player and Wikipedia searcher, and it has a really distinct UI. I love its UI, and there were some issues with me continuing to sell this app, and so I decided to put it on GitHub. So if you want to see my first Mono Touch app, warts and terribleness and all, it's there. Perhaps a studio. But actually, I have to be a little thankful to that app because it bought me a little time. It actually made a bit of money and bought me enough time to write a real app. And this is iCircuit. This is what I consider my first real app for the iPad and something that's actually useful. It's an electronic, digital, and analog circuit simulator. That's enough about me. Okay, let's get back into the presentation. So there's one thing that I want to drive home in this whole presentation. You could ignore everything else, but understand this. iOS has a vast amount of APIs and libraries and things that you can do with it. It's a very large platform. And for that reason, I really don't have any ability to cover it in the detail that I would love to. But I'm going to try. It's broken up into 4 layers. Cocoa Touch is kind of the famous one that you've all heard of. In it is UI Kit, the user interface library. Game Kit for working with, your Xbox Live, but not Xbox Live. What does Apple call it? Game Center. You can tell I do video games a lot. And then on top of it, we can ignore Cocoa Touch. It's just UI Kit. We have this huge media library. In it is Core Graphics, which is a very high performance and very high quality renderer. You throw polygons and circles. It's a very good anti-aliaser, very good blender, has a lot of mixed modes. Core Graphics is awesome. Think of it as system.drawing, but done right. You have image I/O, which does your pings and JPEGs and GIFs, but it also can handle RAW files. So you have really advanced codecs in there also, or not advanced in that case. You have core image, which is very highly accelerated image filters. You can write little kernels of code, and it'll just blast it through. Some of it even runs on the GPU. So you get this is all your like 1970s filter and your black and white. You can write those things very efficiently. Definitely fast enough to run it off a video stream at 60 hertz. You have core animation, which is this. I'm just boring you guys because I love this library. There's just so much here. It's a 3D render. You have OpenGL for OpenGL. You have SpriteKit. If you ever wanted to make a game, here's a full 2D game engine. Just start writing. There's a physics engine there. Throw in your sprites and start making a game. And then on top of all of that, all that greatness, you have AV Foundation, Assets Library, Audio Table. I don't know what, there's like 4, 5, 6, 7, 8 of these, all dedicated to video and audio. This platform, you can play audio in 8 different ways, and you'll never know which one's the right way, but it'll work in all 8 different ways, and it'll be fantastic. It's a very media-rich operating system. Then we have a few services. Foundation is one that you'll never want to touch, but you're going to have to touch if you do iOS programming. What Foundation is, it's the BCL. It's system. It's all your collections, your networking, data streams, serialization frameworks. It's all the garbage you need to be able to program on a platform. And so when you do Xamarin and iOS, it's kind of cool because you have basically 2 foundation libraries, 2 collection libraries you could choose from. You can stick with the .NET stuff, but there are benefits to the Cocoa one. It's a mature library. You have core location for GPS, core motion for wagging your phone around. Multi-peer connectivity. Do you want a random mesh network between peers all using a phone? That just happens. You just call a little API. It's magic. You have JavaScript core. So do you need a little scripting language in your app? Or maybe you're kind of crazy and want to write your whole app in JavaScript. You can do that now. JavaScript has access to the Objective-C objects and that graph, and there's a bridge to bounce back and forth. There's core data, which is a ridiculously large ORM, relational database. They give it to you in like an object-y way, but it's a database. And sometimes it works over iCloud. Then you got the other junky things like social and passkit. No one uses those. Then just for the performance freaks out there, there is the Accelerate framework, which if any of you have ever done any scientific computing, there's libraries like BLAS and LawPack and just these high-performance matrix libraries, and they give it to you, and it's optimized for the ARM, and it's really fast. It's so cool. You got core Bluetooth. It's going to be important with the iBeacons coming up, but this is kind of the low layer. You don't really use this. You use like the multi-peer connectivity. There's other ways to do networking than to use the low-level stuff, but it's there for you.
You know if the matrix math library, is that built on top of SIMD?
It is hand-optimized assembler, and it'll shell out to the GPU if it can. It's awesome. There's a great WWDC talk given on it, and they really stress the point. It's not just about performance. Like, okay, so you can render at 3,000 frames per second. Does that matter? And it does matter because it's less battery time. Every cycle of that CPU costs you battery time. So if you can cut those CPU cycles, you actually save a lot of power. The nuts and bolts of it is you got to read the manual. There's a lot here. You should go to this link, get a bottle of wine, and drink, and read every programming guide on this website. Yep.
With respect to the APIs, how would you compare in terms of scope and breadth the iOS API that you just covered with Android?
I think it's much larger, much more mature. Yeah, Android feels like we wrote an operating system from scratch. All of this, iOS feels like here's a 15-year-old mature operating system with every feature you could possibly want. It's my perspective. Yeah. So you can, Apple has excellent documentation. Their programming guides especially. They have API references. Problem is you're going to have to learn to read a little bit of Objective-C. in order to understand these, but the truth is I spend most of my time in the Apple docs. And so it's worth taking just a moment to learn how to read an Objective-C declaration. This is a method declaration at the top there. The method is called present view controller animated completion. That is, the parameter names in a method are a part of the method's name. When you call it, the second line down there, starting with self present view controller, you actually call out every parameter name gets matched with the argument value. And you see this one's a little special. I'm using an advanced Objective-C feature, a little block at the end. They got anonymous methods in their language. That's pretty cool. But that gets translated to C#. I'm being... What's neat about this is instead of having that continuation that you have to pass around and otherwise turn your code inside and out, it gets promoted up to a task. So now all we have to do is when we want to present a view controller, we can just await it. So what you have is a one-to-one mapping between all the APIs, but there's a little bit of interwork between them, a little bit of .netifying the Objective-C API, and it's all to just make your code prettier and more pleasant to read, more .NET-y. Fortunately, the team has created this little website that if you ever do find yourself in a rut, like you're reading a website on Objective-C and you want to know what the monotouch equivalent is, there is a Rosetta Stone, nicely named, that'll give you that mapping, and you can just do a quick correct through it. That all said, Xamarin also has an excellent documentation portal. Guides, tutorials, API reference code, it's all here. The API, most of the APIs are documented, at least you'll get your types out of it. There is a great monodoc app that's, I think it comes when you install Xamarin Studio. Yeah. You can see all that documentation in an app on your computer or online here. And with that, we're going to move on to the best part of this all, and that's UIKit for building user interfaces. And as the kitten says, well, I'm not even going to read it because that's embarrassing. I wanted to start hot. I didn't want to bore you with a few more slides on philosophy and architecture. We're all programmers, so I want to start with the object model. Like, what is your app when it's executing? And it all begins with this, I'm sorry, let me give you my notation here. It's poor man's UML. These are class names. So we actually have an object of the type UI application. That gets created for you by the operating system automatically. Your first chance to participate in this chain, you become this thing called an application delegate, which is very mysterious sounding, and I'm just going to leave it there for the moment. You are responsible, though, for creating a window, and that's where things really get started, where you get control of the device and you can start dictating terms. A window in iOS is not like Windows from Windows. Wow, this is not going well if I keep saying Windows. You can't layer windows. There's only ever one window in an app, and that's a lie. But from an application developer's point of view, there's only one window in an app. So no worries there. Every window has a thing called a root view controller. Has anyone out who has not learned iOS yet heard about these view controllers? I used to think of them as like the modern pointer. You know how people didn't want to learn C because they were afraid of pointers? I think people didn't want to learn iOS because of the view controllers. They're kind of a funny class, a funny object. It has many roles, and yet they're optional. It's very strange. And so I want to take a moment to discuss it. A view controller is, in fact, a controller in the MVC terminology. What it's supposed to do is just monitor, coordinate user interactions, that is, pay attention, and interface between the user and the model, the data store, and the services, and all the things the user wants to be able to do. You have to mediate between those two. So that is to say, a controller has a pointer to the model, very abstract, and a pointer to the view. But a view controller, excuse me, a view controller in iOS is quite a bit more complicated. It is logically that thing that I just described. But in iOS, it's so much more. It is almost a user interface element unto itself. You can think of it as a screen of UI. That is a full screen of the UI. And this was very true in the iPhone days, not so much true in the iPad days now. But the important thing is that iOS requires it from a window. So you're stuck with them in some ways. Oop, oh, stupid animations. Don't put too many animations in your slides. It never works out. See, a window has a root view controller, and you have to fill that in. And so at first you're going to think for a single screen application, it's a little strange because your view controller has a pointer to the model and a pointer to a view. And it's weird to have this little middleman in that exchange.
Would you say it's logically equivalent to an Android activity?
Yeah, logic. Some would say a fragment is probably a lot closer. But in the earlier days, I guess. It's philosophical at that point. But continuing the object model, a view controller points to only a single view, but a view can be a whole hierarchy. So you can have subviews and layers and all that good stuff. Things get more interesting when you have a multi-screen application. You just have to think about this hierarchy being repeated. So if I have 2 screens in my app, I have 2 view controllers that I implement. Those view controllers each control 2 separate view hierarchies. And then the app is a matter of bouncing between these different view controllers. So you could think of it as a page, I guess, in Windows Phone. Definitely an activity. It's definitely philosophically an activity. Enough about the crazy thing. I'm going to skip it for a minute and go back to views because they're more interesting. A view is exactly what you think it is. It's a graphical rectangle on the screen. In the iOS philosophy, they're dumb. They're controlled by someone else. So they should not be talking to the model. They should not be listening to events on your whatever Twitter feed, data source, or whatever. There should be a middleman, and that should be the controller or a view model if you want to break paradigms. It's responsible for drawing itself. Usually it's just a solid colored rectangle. You can throw in subviews, so you can compose up forms. It can receive touch events and gesture recognizers because it's a giant touch screen and you better pay attention to those. And I put this here for completeness, but I really don't want to bother you with this detail. It participates in the responder chain. The responder chain is just, remember in XAML all the games they had to play so that we could have bubble up events work correctly? It's just their method for doing bubble up events in a user interface. I like to think about views as falling into 4 categories: output views, input views, big scrolling complicated things, and custom ones. The output views are exactly what you would expect. You have a label, you have an image view. Even better though, you have a Bezier path view. It doesn't end with the word view, but that's great for rendering vector graphics. So if you had the initiative, you could write like an SVG parser, throw it into a Bezier path view, and it'll show up on the screen very nicely. I think only XAML has that. I don't think Android's very intelligent for, okay, it doesn't have any retain mode graphics, I don't think. We have activity indicators and progress views because what app wouldn't be complete without boring the user? We have input views. We have a button and a switch, formerly named a checkbox, but it's now a switch in iOS. We have a text field for our single line input. Segmented control, which replaces the Windows list of radio controls. Now it's just a bar and you select tabs. It's kind of like a tab thing. We have a stepper, which is your up and down control, and we have a slider, and you should never use a slider because users hate them and they just don't work. Now I want to move on to the big, complicated, scrolly type views. These guys are what you're going to use to compose your main screen of applications. The granddaddy of them all is the scroll view, and it does exactly what you think. It can take content that's bigger than itself and allow the user to scroll around. Some especially nice things is it has the patented Apple bounce. So the only way to have patented Apple bounce in your app is to use a scroll view. That'll also give you velocity scroll. And I use it pretty much everywhere because even if you have a static UI, it's still kind of fun to be able to flick it and have it bounce. So I like putting things in scroll views.
So the UI view is strictly fixed for the size of the screen?
Yes, you can think of the scroll view is a rectangle, and its content is much bigger than its rectangle. And the user can scroll, but they can also zoom. good at that stuff. Think about Safari, pinch to zoom in Safari. It's doing that. Now there are a few specialized scroll views because not everyone likes to work at a low level like that. And the big granddaddy of all of those guys is the UI table view. This is essentially the basis of every iOS app, at least in iOS 1 and 2. Everything started out with a table view. You know it, you love it. It's the gray thing that scrolls really smoothly that Android still can't match. It's used everywhere. We use it for long data items. We use it for form input. We use it just whenever we want the bounce effect. It's just great. Oh, and then in Xamarin, it is kind of a pain to program the table view, to be thoroughly honest. And so Miguel de Icaza wrote this nice class, MonoTouch Dialog, way back in the day, to really simplify the interface. Because table views were the basis of pretty much every screen in your app, he was just getting tired of going through nonsense. So he created a streamlined interface to it, which is quite nice.
Why was it difficult in
I'll show you.
Okay.
It's not difficult in Xamarin. It's a very versatile generic class. So anytime you want to do something, you have to deal with its generacy.
I see. It was just difficult generally.
Yeah, you wanted some streamlined, I want a form, I want a data list, you know, some modes, some help.
It's not more different in Xamarin, or not more difficult in Xamarin than it is in iOS.
Yeah.
No, I think,
The data adapter pattern that they use,
yeah. It's actually an okay pattern too. It's just very general, so it's a bit of effort.
Sorry if I'm jumping ahead on the table view. Does it provide services like virtualized scrolling?
Yes, and that's what the complexity is. I should have prefaced that all these big, scary, scrolly things are big and scary because they're all virtualized. Pretty much anything that can display more than a few views in iOS is virtualized. It's a big deal to getting that butter smoothness and working on that stupid iPod Touch 1. But the reign of the table view is ending. Collection view is coming.
We were discussing virtualization earlier.
Yep.
So there's at least two types of virtualization.
Yep.
One is the kind where you provide a list, say, to a table like that, and it doesn't necessarily have to read the entire list and retain that in memory.
Right.
And then the other kind is you don't even necessarily have to provide the whole list up front.
Right.
Does iOS have both of those models?
Not both. It only has the
First
no
one.
list. No, the no list one. It asks how many are in there. Give me this index. So it's purely virtualized. You don't give it any list at all.
I see, and then when you go off the screen,
Yeah.
then it just dumps the value.
I actually have slides on this, but it throws them into an off-screen cache. It saves it there. Whenever it needs a new one, it tries to pull from its off-screen cache, and then it rebinds the data. You get a chance to rebind to it.
Understood that.
Yeah.
It's a question of, say you're at item 100,
Mm-hmm.
and then you start to go back.
Mm-hmm.
You then get asked for item 99 and item 98.
Yes.
Okay.
All over again. Nothing is retained.
Okay, so that answers my question.
Yeah. Very low memory design.
The cell is reused, right?
The view, the
Yeah, I
cell,
guess-
yeah.
I totally
Yeah.
know that.
Collection view has the exact same data model, except this one's a lot more versatile. A table view is just an up and down list. This one can have any layout you can possibly imagine. It actually has a pluggable layout engine, so you can write your own crazy. You can actually hook a physics engine into this thing and use that as the layout, and it becomes a little physics engine game. You could write Pong in here very easily, just using a collection view. The collection view is the best class ever created by mankind, because it allows you to just have an infinite amount of data arranged in any fashion, and it pulls it very efficiently. It does all the off-screen caching and all that stuff. Nothing. And then in iOS 7, it actually became even more important because there are transitions between view controllers now to just make the screen even more nicely animated. And you'll see whole apps like the calendar app is just 3 or 4 screens of collection views. And it's not custom views doing custom rendering. It's just collection views solving constraint problems with a crazy layout engine. You have a web view. Don't use them. You have a rich text. I want to go. I'm sorry. They're fine. They're very efficient. It's JavaScript runs excellently. You can access the DOM. You can run JavaScript. They're great. I said don't use them because it's such a powerful view. It's such a powerful class. It's basically a browser just in a little control. And so people they keep putting their little ghetto browsers in their apps. So whenever you click a link, it takes you to the app's homemade browser, and then you're like stuck there and your cookies are all wrong and you can't get to your bookmarks, and it's really annoying. So if you ever write an app that needs to shout out to a website, shout out to a website. Let Safari open it.
So
Um,
this is true for Android. In my development, it's going to be true for this too. What about if you just have your privacy policy and your terms of service pages that you want to be consistent across all your apps? They have links that might actually link to other pages in the same app.
You didn't let me finish. I was going to say, and this is great for documentation. Yeah, I mean, HTML is awesome for a formatted document system, and use it for that, 100%.
Can you link to other screens in your same app?
Yeah, it's fantastic because you get events when someone clicks, like on down. You can hook into all of it.
Are you saying that for documentation you would embed resources in your app
Yep.
and display it on the
Yeah, do you, golly, I hate going back in slides because I can never, but we saw this app. That is a UI web view showing the puppy dog down at the bottom there, because I wasn't going to write a text layout engine and all that. So I actually take HTML, scrape out all the formatting, replace it with my own formatting, throw it into a web view, and let it look this very distinctive style. How are we on time? Oh, sweet. We have a text view, full rich text editing, now in iOS 6. So bold, underline, color, font, that's about it. You can make apps from it, though, amazingly enough. You have the UI picker view, which was way more common back in the iOS 1 and 2 days when we were all excited for these new devices. They're the big, I don't know, roulette machine. I don't know, some kind of stupid. It's dumb. Don't use them. And there's a much better way to do user input. And last but not least, you can always make your own UI views. The easiest way to do this is just through composition. You can think of your old Windows forms where you create a user control and you just start piling on other controls onto it. That's obviously the best way to go. It's actually quite easy to do it in code. This would be a custom view, and I'm sorry I faded that out quite a bit too much. This is a my view, inheriting from a UI view. And all it's doing is, well, I'd even put that code. It doesn't even create its children. It just adds its children and lays them out a bit. The big problem with composition is layout. Now, you can use a designer, but even designers, you have to deal with the rotating the device, the difference between iPad and iPhone, the difference between the two iPhones, and hopefully the next iPhone. But even people like me who do stuff in code, well, we're a little bit stuck because computing numbers like this, I think we've all done it. Like you have a rectangle and a rectangle, and you calculate its offset from that other rectangle, and then you set it to that frame. It's terrible code, and if you go look at that RSS reader's source code on GitHub, you'll see it's just every line is a rectangle F, just me computing a new location for a stupid button. Well, they fixed that in iOS 7. They added this constraint-based language for doing layouts. And I'm not going to show it to you how you're supposed to program it from the API because I think the API is horrendous. So I wrote my own API for accessing it. I'm going to show you that version because mine's way better. So all you have to say in mine is you still add the subviews, but then you set constraints, as in the progress frames middle, horizontal middle, mid-x, should be equal to the time frames mid-x. And you can do less than or equal to constraints. And you just set up a few constraints, and blah, there you get a fully resizable UI that works right on the 5th or 6th time. It's easy to create over-constrained scenarios and under-constrained. I would say mostly people create under-constrained scenarios, so they have like a view go flying off to the side. They have no idea why, but it's fun. Yeah, it's an absolute positioning declaration of relative position. So you can never say that my left should equal 12. You can say my left is equal to this view's left plus 12. So in that case, it's 100% absolute, but the declarations are relative. No. UI collection view does a great job at flow control. No, this is bad. And actually, they say it's a rite of passage is when you start adding and removing constraints while your app is running to get the UI to do what you want. So it gets a little nutty, and you really don't want to go down that path. So yell at your designer or rethink it. But don't implement that. Your last way to implement a custom UI view is to just draw it yourself. I told you there's that core graphics layer, and it's really easy to use. And yeah, you should just do more of that. It's fun to do programmer art. So those are views and how they present themselves, but the real important thing is how does a user actually get to interact with your app? We're not just making videos here. In the olden days, pre-iOS 3, we didn't have these things. It was a dark time, and we all wrote very procedural, on mouse down, on mouse move, tracking positions, and losing your state and never resetting it correctly, and then never being able to do 2 gestures at once because then the state variables are really crazy. So in iOS 3, I think, they introduced gesture recognizers. These are objects of specific types. We have long press, pan, pinch, rotation, all these little gestures that you would ever like to do. And you just add them to the view, and they spew out events when it happens. And it's very easy. They have a very strict state machine that is documented, so every gesture recognizer obeys the same state machine, so it's really easy to write predictable code. And then the really neat thing is gesture recognizers can communicate with each other. So if you have a panning gesture recognizer that gets to the edge of some content element, it can say, oh, I want to cancel myself and allow another panning gesture recognizer to take over, or one can supersede another. There's a very nice interplay that these guys can participate in. All that means to you is that your app responds in a way that you would expect. It doesn't go crazy if it gets 2 gestures happening at the same time. You can even implement your own gesture recognizers, and this is great fun because you do get to still write that old mouse up, mouse down, mouse move, but they're called touches began, touches move, touches end, touches canceled. And I still write all my code this way because it's fun. So I mentioned this guy before. We got to get back to him because he's unavoidable. Again, this is just our view controller. He has a pointer to a view and a pointer to our model. And we use him to implement screens of our application. But there are a few built-in ones that are better, that actually do try to help you out a little bit in your app. The granddaddy of all these guys is the navigation controller. Every iOS app should have one of these somewhere in it because there's really no, this is presenting, I click a button, we move to the next screen, and I have a back button. So this is probably a terrible screenshot because there's so much going on. But you see there's a left arrow in the top left saying circuits. That's a back button. This navigation controller is actually a hierarchical one. You pass it your inner view controller, and it wraps around it. It allows it to push onto a stack. It maintains a stack of view controllers. And in addition to all that, it gives you a nice bar at the top with the back button, and you can put your other buttons and titles there, and you can have an optional toolbar at the bottom. It's quite funny that if you try to create your own view and make your own bar and a bar at the bottom, they won't render as nicely as if you do it through a navigation controller. Apple takes shortcuts or optimization paths or whatever you want to call it, but you really want to use navigation controller because all the rendering is prettier. There are no graphical glitches or anything like that. Then we have our tab bar controller. And we've all seen these. They're always at the bottom of the phone. And you can get to your Miley Cyrus song or whatever you're into. Oh, look, I didn't replace the graphic. More Miley Cyrus. We also have a split view controller. This is the Mail app on the iPad. Just imagine it's a split. There's a left side and a right side. It does that for you. We have the page view controller, which I personally love. It gives you that page turning effect. So any of your apps can have this little page turning effect. And then there's 2 other view controllers that you're going to use a lot, the table view controller and the collection view controller. They're exactly what you think. They're just controllers that already have their view set up to be a table view or a collection view. Oh my God, we're almost done, I swear. This guy's cute too. He's the popover controller. He was introduced with the iPad because we hated all this full screen stuff. He's a little weird because he's not a view controller. It's actually just another kind of controller. They like the word controller over at Apple. And it controls view controllers though, so that's kind of cool. And it allows you to do this little popover. I wanted to get into a little bit of theory, but you're not all looking too energized. So we're going to cut the theory bit a little. But I just want to give you a few little warnings. There are a lot of event sources in a user interface application. We have our old .NET events. We have overridable methods, so any class you inherit from, you can consider that an event. We have all of our async tests running. And then, in addition to all of those that we have to deal with, iOS provides 3 more whole large sources of events that can come into your app. There's this global one called the NS Notification Center. Any object can subscribe to it. Any object can post to it. So you know that's not being abused. You have the responder chain, which is your user interface bubble up events. So if a click happens here and no one responds to it, it just keeps going up the view chain. It's actually a responder chain. That's why it's not the view chain, but it doesn't matter. And then you've got these other things called delegate objects, and these are not C# delegates. These are not .NET delegates, but they both chose a good word for the same reason, because it does delegate event handling. But what these are is, well, instead of having, say I have an object and it says I can shoot a missile and shoot a laser beam. You have 2 events, shot missile, shot laser beam. Well, instead of having those 2 events on the object, and having anyone subscribe to them and having it be a very flexible architecture. Instead, Apple says, well, there's just an event handler object, and that's called the delegate. And we're going to call methods on it when these things happen. So your delegate in that case would be like on missile fired, on whatever else I said. It's a simpler model. It's a little easier to subscribe to a bunch of events and revoke your subscription. But it's less versatile because you can only have 1 subscription to that event, obviously, a few other things. Just something to watch for. You're going to run into it, and it's going to be fun. Oh, and here's a little code demonstrating. This is a delegate I set up to handle some events from the UI split view controller. So it's not even events. Sometimes it asks for information, so there's a 2-way, and I guess that's why it's good that it's a single object, but still kind of weird. So here's a delegate. You can think of these as 3 events. And that's how you would do it. Another thing is this virtualization of all the views in here. This is a lot of fun. It's not so bad. The principle is you usually provide a data source to the control, and that data source will just have some methods on it that you have to implement. Most notably, whenever you do this, it's usually because you're working with a table view or a collection view, and you want to get a cell. A cell is just a unit of information in that view. And this is what that code would look like. First, you ask the view, do you have one of these cells with this identifier in your backing cache? If it does, it gives it to you, and you'd get a cell that's not null. If it doesn't, then you get null back, and you have to create the cell. No big deal. And then you pass it back, and it all just works because next time it DQs it, it'll put it back into its cache. So it's not a lot of code to write, but it was enough to get Miguel to write an abstraction over it. Yeah, basically, yep. And I didn't want to correct you, but that's not a backing store. It's just a user. We'll get into it, but.
The difference too on Android doesn't do that for you. Android makes, I have an entire blog post this week about it on a thing. Android doesn't do that by default. You have to wrap it, and then it'll pass in a view, and you have to cast it, and then it's like a convert view.
Yeah.
So Android, the adapter, which you think this is, it's a app, but the adapter is not smart. It's really stupid. It expects the developer to do
a little bit more work.
Yeah, but
stuff like where the inflating comes in.
Yeah, so you inflate the view, which is going to blow up to XML, and you have to shove it in a temporary view, and you store it off in the tag.
Your optimization.
And then you grab that item that you wrapped back in the object. But it's
in other words, iOS wins on this one.
So anyway, so it's similar to Android. But, yeah.
And just because I'm being pedantic, here are 2 other guys with data sources. There's a page view, picker view. You're going to have to deal with it there. There's also theming built into OS. This was bigger in the iOS 6 forestall era, where we were all theming our apps. And now we all just decided to use solid-colored rectangles and text, I guess. It was cool there for a little while. This is how you do it. The neat thing about theming is you can apply it on an object level or class level, so every UI button would look the same way. And that's built right into the API. There's actually just a static property hanging off of the class, and you can just start telling it what to do. It's a limited theming support, so you have to set up your theme in the beginning and then start creating your views. You can technically change parts of it while it's running, but not reliably. And then I was going to go over just real quick, just to make sure everyone's on the same page. Here's the Maps app. Here's its view controller hierarchy. We have a navigation controller, and then holding the app's actual controller, the map view controller. And then we have the view hierarchy. I just want you to see that we have a navigation bar with a few other little things in it. We have a map view, which has overlays in it, like the little dot for us. And we have a toolbar at the bottom. And so it's just a little tricky to get your head around how many hierarchies there actually are in iOS, because we have the view controller hierarchy, the view hierarchy, the responder hierarchy, the object hierarchy, and the layer hierarchy. And sometimes you actually have to know what each one's doing, unfortunately. Ah.
It looks like your red square is overlapped by the navigation.
New in iOS 7, yes, the red square is in fact.
For the life of me, I cannot figure out how to get that layout. Even the simplest.
Another use for the scroll
Do
view.
not be overlapped by it.
Use a scroll view with a content inset, and then you get bouncy effect, and it fixes that problem. I'll work with you on that. A scroll view can get you a long ways. It depends on how much data. The collection view, honestly, is probably the way to go, because it's so efficient with how it can off-screen stuff comes out of memory and it comes only back into memory when it's on screen again. So that's a great base for a thing where you have a lot of stuff to display. Yeah. 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 You may know that you can view photos on the iPhone, and they wanted that to be very efficient. So the scroll view is able to, there are lots of shortcuts in iOS where if you put the right object in the right position, the iOS can take a lot of efficient code paths. And one of those is that you can actually set up a tile layer in a scroll view, and it's specifically designed to bring bitmap data in and toss it out when it's not needed. So you could implement infinite scroll, infinite zoom, whatever, because it's handling the throw the bitmap out, I need a new bitmap, and then you... It would be a view that you put inside the scroll view, so you create a tile layer, you obey the tile protocol, and then the scroll view will shortcut itself and just start poking at you. No, you can abuse the heck out of scroll view. It's amazing what you can do with that thing. The really neat thing about scroll view is you can put scrolls inside of scrolls, and they actually obey each other nicely. So when you get to edges of content, the larger scroll view takes over. I don't want to get into it because let's do a demo. So I wanted to show you a little bit of programming. Gotta roll up my sleeves. Whew. I love programming in front of people. And I know you love watching it, so I made this the dumbest app I could possibly think of. But the neat thing is, this is an app that will only work on an iPhone 5S, and that's because it's going to take advantage of the motion coprocessor on the 5S. Which is kind of the whole point of this, is that if you go native and you just pick a platform, you can use all the fancy little features on the devices. And so I figured, well, if we're going to learn iOS, let's use something that you can only do on iOS. So we're going to create a pedometer app, or a step counting app, however you want to call it. And we're going to do it at 1024 by 768 resolution, amazingly, somehow. This is Xamarin Studio at 1024 by 768 resolution. And very simply, I'm going to create a new C# iOS project there are lots of templates to choose from. Storyboard being one. Storyboard's very cool because you'll be able to use the built-in designer built into Xamarin Studio. It's not quite fully finished yet. It's not stable. And I tend to write all my UIs in code. And I hate to tell you that's the right way to do it, but it is.